Good evening, Bearcats. Okay, this is Unit 8, 3.5. This is our last algebra section before we start trigonometry. You will have several questions on your test concerning exponential models, and we will be focusing mainly on the finance and the half-life models. The formulas that you need to know are the following. You need to know if you are compounding interest, or your interest on your investment is compounding continuously. These formulas came from our last test, but if they are compounding continuously, then the formula is the amount is equal to the principal, and it's e raised to the RT power. Please do not forget that your rate of interest must be in a decimal form. So that means to the left to go from percent to decimal. If your investment is being compounded any way besides continuously, like quarterly or monthly or weekly, then you're going to be using A equals P, and then it's 1 plus the rate over the number of times compounded raised to the number of times compounded times time in years. So if it's quarterly, then the end value would be 4. If it's monthly, the end value in both places would be 12, etc. And finally, then the half-life formula. The half-life formula that we're going to use would be the amount that is left of the substance after your initial amount. We went ahead and left it as P. It would really be I or C as your initial amount. And it would be to the 1/2. And then 1/2 would be raised to T over half-life. Time over the half-life years. And that half-life years would be given to you. All right, I want us to look at 3 examples. We've seen these formulas before. We saw them last year in Algebra 2. I want us to look at 3 different examples tonight that utilize this information, and I want us to work through those problems. And then tomorrow in class, we will finish up our 3.4 classwork, and we will start on maybe even on our review tomorrow to try to make sure that we're filling in any gaps where you are missing. So make sure we've done 2 sets of classwork that you understand that. Please go back and look at the videos, and we will catch up more in class tomorrow. All right, let's move on to our first example. Like I said, we're going to do 3 examples. The first example we're going to do is over radioactive decay or half-life. So it's radioactive decay, which would be utilizing our half-life formula. Again, we're going to go ahead and set it up as A equals P 1/2, and it would be time over half-life, and I'm going to just say, often you'll see this Y equals C 1/2 times half-life. Okay, just so you know. Y is basically, or A is the amount after time has passed. P or C in this case would be your initial amount where you began the problem, and of course half takes into the account that we're talking about half-life. All right, in this following problem, we have the half-life of a certain substance is 65 days. So this is going to be that the half-life is equal to 65 days of a particular substance, and that initially we started with 3.5 grams, and we want to know how much will be left after 42 days. Okay, so that's our question. So we're going to plug into our half-life formula. So we want to know how much will be left. So we want to know the Y value or the A value. So the amount that will be left when we start with 3.5 grams, and we're going to say multiplied times 1/2 raised to time. Okay, so our time is 42 days later, divided by the half-life, and we know our half-life is 65. And that's what we would do. We would put that in our calculator. You're going to have to be very careful when you put these things in your calculator that you don't make careless mistakes. If it were me, I would put 1/2 or 0.5. You might even write this as 3.5 times 0.5 to the 42 over 65. I would put in 0.5 in my calculator. I would raise that to, and I would put a parentheses around 42. divided by 65. Sorry. So I'm just doing this in my calculator now. So 0.5 raised to, I would put parentheses, and that would be 42 divided by 65. I would enter and get that value, and then I would multiply that. I would not take it out of my calculator, would not necessarily even write it down. I would multiply by 3.5. So take that value and then just say times 3.5. And I get approximately 2.236 grams. Okay, 2.236 grams. Well, we know in 65 days we would have half, and half of 3.5 would be 1.75. And we're not halfway, we're a little bit more than, all right, we know that in 65 days we would have half of your substance left, and we know that in this case half would be about 1.75, and we haven't gotten close to 65 days yet, so 2.236 grams seems like a reasonable answer. And I would make sure that you think through that. So in other words, if it were 120 days, there'd be more than or less than half left of your substance. So just make sure that you're thinking through the problem. All right, let's take a look at a couple of finance problems next. The first problem we're going to say is number 1. We're going to have 2 of these. And we're going to say John invest $2,300. Oops. $2,300 in a savings account. And he receives 9% interest. Immediately before I go on any more in the problem, I'm going to cross this out, and I'm going to write 9% as a decimal. So I'm going to go to the left, so 0.09 is my decimal. That's my rate or my percent. 2,300 is my initial or my principal amount. That's important. And we want to know how long, so how long. So time is our question here. How long will it take for the account balance to reach? So it's going to reach the balance to reach, and we're going to say $4,150. $4,150. So to do that, to figure that out, our balance to reach $4,150, then that would be our amount at the end after time. So this is our A, this is our R, this is our P, and we're looking for time. And since it is compounded quarterly, sorry, that's one thing I didn't do, it was compounded quarterly. All right, and if it's compounded quarterly, there's 4 quarters, and so that would equal our N value in our equation. So the equation, because it's not continuous, you can't use the equation with the E in it. You have to use the equation that is A equals P times 1 plus the rate over the number of times compounded raised to the NT power. And we're going to be solving for T, it looks like. So let's plug everything in. We know the balance is going to reach $4,150. I like to move my A to the other side. I've always done that, and I'm going to continue to do that. So our principal investment was $2,300. So we have $2,300 times 1 plus. The rate we know is 0.09. Number of times compounded were quarterly, so that is 4 raised to the 4, and we don't know the time. But we know all of this is going to equal $4,150. We just don't know how long it's going to take to do that. All right, that's really important that we understand that. Oops. So let's keep working through this problem. So the first thing I would do is divide by 2,300. And I would have 1 plus 0.09 over 4. Raised to the 4t power equals. And if I divide 4,150 by 2300, I get, oops, I get approximately 1.80435. But instead of rounding, we're going to wait to the end to round. So what I'm going to do is I'm going to leave this as 4150 over 2300. So if it doesn't come out to a nice pretty whole number, I'm just going to leave it. Okay, at this point, I have this blob of information raised to this power. And this power has a variable in it. So I have an exponential equation. This is the base of my exponent raised to this power. So the base of my exponent is going to become the base of the log. So I'm going to remember switch forms, and I'm going to write log, and the base will now be 1 plus 0.09 over 4. And then these two amounts are going to switch, and then it's going to be to 4150 over 2300 equals 4t. So I'm going to take all of this information right here, and I'm going to divide by 4. And that's what my t value is. So I'm going to rewrite that over here just to show you one more time that my time is going to be equal to log base 1 plus 0.09 over 4 to 4150 over 2300, all divided by 4. All divided by 4. So putting that in the calculator is going to be a little tricky. So I am going to do a couple of things here and to see what happens. So if I take 0.09 and I divide it by 4 and I add 1 to it, I get, for this part right here, I would have log, and I would have 1.0225. And I'm going to go ahead and take that 4150, and I'm going to divide by 2300. Oops. And I'm going to get 1.80435. And I want to take all of this and divide by 4. So I'm going to do that in my calculator. So I can pull up my log key in my calculator, control, and I'm going to type in my base is 1.0225. I'm going to tab to get to the other part, and that is going to be 1.80435. I'm going to hit enter, and then I'm going to divide that amount by 4. And when I do, my time is approximately 6.631, and this time in this problem was in years. This time was in years. And there's my example. I would make sure I understand how to set this problem up fully, and tomorrow you might take from this point of the problem and see if you can put it in the calculator and get the same answer. And then we have some to practice in class as well. All right, last problem of the evening is also about finance. It's going to be a compound continuous problem. So this time, this is our third example of the evening, and it is again over finance. So this time we have Joelle. Okay, Joelle invests $8,000. Okay, that's the initial amount, so that's going to be our P value. All right, they invest $8,000 into a retirement account. This time we're going to say at 7.2% interest. Immediately I'm going to cross this out and write 0.072 because that's going to be my interest, and that's going to be my rate. And they're going to invest this continuously. Okay, so that means I'm going to have my E in my formula. That just kind of gives me the idea of E. And we want to know how long it's going to take for it to double. How long, oops, which would be our T value. That's going to be our question mark, to double. So let's set this up. We know we're going to be using A, the amount, is equal to PE raised to the RT power. We know that because of the continuous. We had this on our last test. So now what we're going to do, we know we invested initially $8,000. That was our principal amount. We know E is the calculator button. We know the rate is 0.072. We don't know what time is, but we know that we want it to double. So $8,000 doubled is $16,000. And that's how we set up a problem like this. If it was triple, it'd be $2,400. You'd multiply times 3. All right, the very first thing we're going to do, though, in solving is we're going to divide by 8,000. And when we do, of course, if it doubled, this will be 2 on this side. If it tripled, it'd be 3 on this side. So we have E to the 0.072t equals 2 in this case. This is very similar to problems that we practiced in class yesterday. So when we do that, we're going to take the natural log of both sides, and we're going to switch to natural log form. So we would have ln2 equals 0.072t. And we would divide by 0.072 to solve for time. So our time will be approximately, and that you'll put in your calculator as natural log 2. I would enter, and then I would divide by 0.072. And when you do, you get approximately 9.627. And again, this is in years. And that would be your final answer. And we will round everything to 3 decimal places. All right. Pay attention to these. Make sure you understand them fully. Make sure you understand how to find the time. If you didn't find the time and you were given the time but wanted to find the rate, it'd be a similar situation. We'll practice some of these in class tomorrow. And make sure if you have not looked at the previous videos, you go back and look at them and really understand that. Again, we'll finish up our classwork that we started yesterday, and we'll move on to our interest and half-life problems. All right, have a great evening, and go Bearcats!